So I will now show you how to operate the nordicMEDiVA dashboard. And as you remember, data is sent from the MR scanner or from PACS into the nordicMEDiVA system, where it's automatically analyzed, and then the results are sent to PACS. The nordicMEDiVA dashboard is a web-based system for configuration of the nordicMEDiVA platform, meaning that it can be accessed from any computer. So the nordicMEDiVA dashboard is what you see here, and we have different pages on this dashboard, and the most important pages are the root page and the queue page. So the root is what decides what will happen to the incoming data, and I will show you now how to configure this. So currently here we have one root listed. So you see this has description DSC, and I can either go in and edit this, or I can create a new one. So I will just create a new one now, and I will show you how that works. So there are two different types of routes that can be created, either a new pipeline, meaning a new type of analysis, but it's also possible just to pass through the Dicom data. So if you have a structural data set you just want to pass through the system, that can be done as well. So I will create a new pipeline. So first of all, it needs to have a name, so we can call it, for example, standard perfusion analysis. We can also add a comment. We can have priorities on the different routes. So in case you have some emergency analysis and you have some other type of analysis that, for example, a long-term research project, then you can have different priorities on these. So how can we actually decide how the incoming data will be analyzed? So which route will fit which incoming data? So this is done using the route filter. So we can use either Dicom tags or network info to actually decide what will happen to the incoming data. So the easiest way to do this is to use the Dicom tags. So here we can use any type of Dicom tag to decide what will happen, or which route will actually be analyzed with the incoming data. So I will now add, for example, series description. So I will just select series description, and I know that the data I want to analyze with this route contains the name DSC, for example. And I can say, okay, it contains that key, and it's case insensitive. So then all data that contains this text will be analyzed using this route. And as I said, I can use any type of Dicom information here, so it's also easy to add customized keys if you want to do that. So that's how we decide how the different datasets will be analyzed. And then, of course, I need to specify what will happen to the data when it comes in. So I go in again to the same one. So you see that I already put the route filter, Dicom tags, but then of course I also need to set up a pipeline for this route. So in this case, I want to do motion correction, and then I want to do DSC perfusion, and then I want to export results. I also would like to add some quality control to the data, and this has to be done using this graph output that actually needs to be exported individually like this. So then we have a pipeline here on how the data that comes in will be analyzed. So for each of these we have some settings that we can edit. So I will show you now with the DSC perfusion how you edit these settings. So we go in here and we see that we have different sort of a layout of how much of the details we see. So we have simple, we can also change to moderate or advanced, and this is just the complexity level of the settings itself and how much we are able to see. So if we set it to advanced, you see that there are quite a lot of settings that we can change here, and this of course is now available for the user. We have different types of leakage correction algorithms that can be chosen, and we can have different types of AIF deconvolution algorithms, either using a predefined AIF or a global detection of the AIF. We can choose here which output maps to generate. For example, here we can choose to include leakage corrected maps, but you can also include the non-corrected maps, which sometimes can be nice for quality control. It is also possible to normalize the data, and you can choose which area of the brain you want to normalize to. So there are quite a lot of output maps that you can include if you want to. So I will just leave it like this for now. We can also include some time curve property maps. So I can include that as well. For example, time to peak, baseline, etc. And then there are just some additional settings, for example, how to detect the bolus arrival time, etc. So once we've set it up, we can go back and we can configure the next one, which is the Dicom Export. So I need to set up these information correctly. So I want to, in this case, send to a Dicom node. I can also save to file, but I would like to send to Dicom node. And I have to put an IP address. So whatever IP address that I have. And then the correct port number that I want to send to and the AI title. So for example, something like this, and the AI title, whatever that is. And once I've set this up correctly, I will save. And then we have a new pipeline, and if the incoming data match this pipeline, then this will be initiated and analyzed according to the settings we just specified.